My name is Andy Humphrey. We're with Stewart Systems. Lucas is in the back here as well. He works for us. Stewart Systems, we're right here in Johnstown, Ohio, so we're local to you guys. We manufacture the fabric covering process. We have one of the 6 STCs that are out there right now for fabric covering. And we also have metal paint primers and the whole system for painting metal, composite, whatever type aircraft you have. But the scope today is going to be on fabric coverings. We're going to kind of stick to that. Just want everybody to know that that is available. How many of you work with fabric on a regular basis? Oh, good. Okay. How many of you have ever used Stewart Systems? Okay, good deal. How many of you have never heard of Stewart Systems? Okay, we got a couple. Good. Okay, excellent. All right, well, we'll get started today. I'll give you a quick history of Stewart Systems. It actually started out in Montana. It was originally it was Aircraft Finishing Systems. It was bought in 2006 by Dan and Margie Stewart and became Stewart Aircraft Finishing Systems. And eventually we dropped the whole aircraft finishing and just call it Stewart Systems, a little bit easier. It was originally in Montana, like I said, then it went to Kashmir, Washington. Now it's here in Ohio. We actually purchased the company about a year and a half ago, so moved it right back here to Ohio. This is Dan Stewart's clipper right there. That was done late 90s, I think. So our system goes back, the aircraft finishing systems actually goes back into the mid 90s or so. Dan and Margie Stewart also used it for a long time before they bought it in 06. The STC actually started in 06. So what is different about Stewart Systems from the other fabric covering systems out there? The primary difference that you're going to see is our system is waterborne. We are the only waterborne system in the industry right now. What that means to you is it is non-toxic and it is non-flammable. Those are two huge things that set us apart from everybody else in the industry. Matter of fact, this is our Eco Bond. This is our glue that we use in our fabric covering system. I'm going to pass this around so you guys can just take a cap off, take a whiff, kind of see what it is, see what is different. If you guys
Get everybody high.
if you're, let me. It's got a little seal on there. But if you're used to using the other ones, you know that if we crack the lid of MEK in here, they're going to know it at the other end of the building in about 3 minutes.
That would help.
Yeah, I'll take that off for you.
Okay, thank you.
There you go. Don't spill it or we'll have a mess. It'll glue carpet real well. But it's also non-flammable. So, those two things, and it's environmentally friendly. So those factors are a huge deal because, if you've got a spray paint booth, now you don't have to worry about it being explosion proof. You don't have to worry about the environmental hazards near as much. So it reduces the cost of using considerably, and it's very easy to use. We won't have time to get into a whole lot of how to cover an aircraft in this topic. We're going to focus more on maintenance and airworthiness on this one. But in the end, the finish is long lasting, it's durable, it is going to hold up as good or better than anything else out there. Matter of fact, what we're seeing on ours is very, very seldom do we ever see a crack in our system, even 2-3 decades out, which I don't think any of the other systems can claim. It is easy to repair. We're going to get into that a little bit. We are tested and certified to Part 23, which most of the other systems came in under earlier regulations that were far more lenient, so it was quite a chore to get the STC. One thing that is a huge factor for you guys in the maintenance field with Stewart Systems is we are certified to repair any STC'd system out there. So if you have an aircraft, if you don't even know what's on it, you're legal to repair it with ours under our STC. You can repair dope, Seconite, polyfiber, Superflight, doesn't matter. Cotton, any of that can be repaired with ours legally. And we do have outstanding customer support, if I do say so myself. So the scope of this talk, we're going to cover a little bit of history, a little bit of fabric covering basics. We're going to hit airworthiness and testing fairly hard because that's the most important thing for you guys at this point probably. A little bit of repair techniques, a little bit of regulations, always important topics. So the history, we started out with cotton and linen originally, going back to the Wright brothers, and really that persisted all the way up into the 50s, pretty much unchanged. Of course, I think Orville and Wilbur probably didn't have any coatings, but gradually we added coatings. We used nitrate dope, which was a problem because it was very flammable. Then we got into butyrate dope along with nitrate dope to reduce that flammability. And that system persisted really all the way through World War II. That was our primary system. The problem with cotton and linen, and they are actually two different products, but we kind of treat them as the same really for our purposes. But the problem is they're susceptible to rot and mold, right? I mean, they're an organic fabric, they're going to deteriorate. So although we occasionally do see a cotton aircraft that has survived the decades, there still are some flying. You may run into them once in a while. Normally, in normal use, you're going to get 5 to 10, maybe 15 years out of cotton, and it's going to need to recover. So that adds the cost of operation considerably. One thing that cotton and linen have in common is they are no longer available. They have been unobtainium for about 2 decades now. So, there may, at least in the certified world. Now, the experimental guys might be using Walmart bed sheets. I don't know, but for practical purposes, it's no longer available. What we're seeing replace it primarily now is polyester fabric. Everything that is certified right now is polyester. We'll get into that in detail in a minute. It is a fully synthetic fabric. There is no organic compound to it at all. It has a much longer lifespan than organic fabric, considerably. It's not susceptible to rot and mold, which is huge. It doesn't matter. It can be wet. It can be laying in water. It doesn't matter. Rot and mold, even if they grow on it, are not going to attack it. So that is a very great thing about polyester. The one thing about it, though, it has pretty much an indefinite lifespan if it's kept from UV. Ultraviolet light is kryptonite to polyester fabric, so we have to protect it from that. It's considerably lighter than cotton and linen, much higher tensile strength. It can be used with dope. You can use the old dope systems with polyester if you like. It's been modified a little bit from what it used to be with cotton, but similar. And you can also use modern coatings on it. It has been used on aircraft since the 1950s. It's not new. It's been around a long time. And it is used with all currently available STCs. So everything that we're doing now in fabric covering is all polyester. There is one other fabric that you may run into in the field, and it is actually a fiberglass fabric. It went by the trade name of Razorback. As far as I can tell, it's completely unobtainable now. I know Paul Workman ran into one last year, so they are out there. They're flying. You can repair it with Stewart Systems if you need to do a repair on it. But most of the time, you're probably going to end up recovering those. There's not very many left. We'll go over fabric terms just a little bit. The fabric generally comes on a roll from the mill, right? So the roll is going this way. So the direction of the weave, this direction is called the warp, and the crossways direction is either called the fill or the weave. People use both terms. And another term you'll want to be familiar with is bias, and this is going across the weave at a 45-degree angle. So you'll see bias tapes. A bias tape is nothing more than a tape that is cut at a 45-degree angle. And you'll notice they're sewn together because the roll is only so wide, and when you get to the end of that, that's the length of tape you have, and you sew them together. So that's where you get your bias tapes. These are all the approved fabrics that we have available to us today, along with grade A cotton for a comparison. Seconite 101 and Seconite 102. So we'll start there. 101 is what we call heavy fabric, and 102 is what we call medium fabric. Now, 80% probably or more of what we sell for going out the door is going to be 102. It's medium weight. There are some aircraft that use the heavy weight. We'll get into that here in a minute. But those are the two primary for Seconite. Polyfiber, they're heavy duty 3 and they're medium 3. Essentially, we just call them 101 and 102, the same as we do with Seconite. And if you look at the numbers on these, here's our weights. This is per square yard, ounces. Over here's our weave, so we've got 69 threads in the warp direction and 63 in the fill. Here's our tensile strength, 125 in the warp, 116 in the fill. So depending on which direction you're pulling on the fabric, there is a slight difference in the strength in some of them. But if you look here, if you look at these numbers compared to Seconite 101, they are identical. So Polyfiber and Seconite are owned by the same company, Consolidated Coatings. These fabrics come off the same mill. It's Buick and Oldsmobile. They're completely interchangeable from a practical standpoint, not necessarily always on an STC standpoint. We'll get into this in a minute. Superflight, though, is different. If you look at the weights, if you look at the weaves, the strengths, it is different. It's the same chemistry, but they weave it differently. So we kind of like the Superflight. It's a little bit finer weave. It's a little easier to work around corners and things, but strictly a preference. Really doesn't matter. One thing to consider, though, if you look at Superflight 102, it's 90 and 90 on the strength, so it doesn't matter which direction the strength is identical. But look what happens on the 101. Now we've got 80 pounds per square inch tensile strength going in the warp direction and 130 in the fill direction. So that may come into play on certain applications, so keep that in mind. Also, if you're testing it, we'll get into that in a minute, that could make a big difference. But look at cotton down here. This is 4.5 ounce cotton. This is heavyweight cotton. And we're at 80 and 80, so with 4.5 ounce. So, you know, the 1.8 ounce polyester will almost compare to the heavyweight cotton. The medium weight polyester has superseded the cotton by far. So you can kind of see the advantage of polyester here in that chart. We'll come back to that in a minute. Here are all the current STCs for fabric covering, as of the publication of this anyway, which is, as far as I know, is still current. There is one other fabric system that I know is applying for an STC. I don't know if they received it yet. That's Oritex. That's the one that's pre-coated that you just glue on and shrink. But at this point, we're going to treat them as experimental. I don't think they're STC'd. Airtech's been around for a while. You know, some of you are probably familiar with that. They also use, you know, the 3 certified fabrics. They don't make their own fabric. Seconite, this is our dope system. Randolph, they're all under this same STC. So basically what we've got here, you know, the products are listed that they're using. You come over to here, the top coat is going to be dope or ranthane, polyurethane. Polyfiber is a vinyl system. It's a little bit different. That's probably the most popular, I would say, in the field right now would be polyfiber. You know, one thing about polyfiber, every one of their products is based with, you know, has MEK as a solvent, which is obviously horribly nasty. They have polytone paint, which is their not so glossy paint. And then they also have aerethane, or you can use ranthane, which is a 2-part catalyzed polyurethane. You come down to our system here, the STC. They didn't list Superflight here. I'm not sure why. This is an FAA publication, but all 3 fabrics are certified with our system. Like I say, we are Waterborne. EcoBond is our adhesive. EcoFill or EcoBond can be used to seal the fabric. EcoFill is our UV protection, and EcoPoly would be the paint. So our top coat is also a 2-part catalyzed polyurethane, but it's waterborne. So instead of using something like acetone or MEK for a thinner, we're using water, which makes it much nicer to work with. And Superflight is also down here. So we've got System 1, which is a dope system. We have System 6. I think they're on System 7 now. I'm not sure exactly what their difference is with System 7, but essentially it's a urethane system. They have a glossy type finish as well. So they're fairly popular. Sources of documentation, always very important in the fabric covering world or aviation world in general. You know, when it comes to fabric, if you're going to do repair on the fabric, you got to know what documentation to use, what instructions to use. So the first thing we could look at is our type certificate data sheet, right? It's going to tell us what was originally on it from the factory. Now, a lot of fabric covering airplanes obviously are not going to have the original fabric covering on it. So, but there are still fabric covered airplanes coming out of the factory today. You know, Maul is one, Carbon Cub. I mean, there's a bunch of them. So we could look at the type certificate data sheet. Assuming it's probably been recovered, we're going to try to figure out what STC we have, and we're going to look at that approved data. This is our approved data for our STC, our procedures manual. Revision 2 is what we are currently printing. We will have revision 3 out at least by Sun and Fun. We're hoping to have it out by now, but we're not quite done with it. Not any huge differences, some minor differences, and we try to really clarify things that people get confused on. So AC 4313 is another great resource for this. We're in chapter 2 for the fabric covering. Another one that people don't really think much about, but the AMT Handbook, Volume 1, has some great information, Chapter 3 for fabric covering. And we actually have Chapter 3 of this on our website in PDF if you guys want to look at that. Most of the graphics from this come out of this handbook, so it's very good information. Okay, we're going to start talking about our testing and airworthiness now. This is an excerpt from the AC 4313, Chapter 2. All components of the covering should be inspected for general condition. Loose finishing tape and reinforcing patches, chafing under fairings, brittle, cracking, peeling, or deteriorated coatings, fabric tears and rock damage, broken or missing rib lacing, and rodent nests are unacceptable. The entire fabric covering should be uniformly taut with no loose or wrinkled areas or excess tension, which can warp and damage the airframe. So this is kind of our initial standard that we're looking at here when we're inspecting our fabric. Let's bore down into that a little bit. It mentioned excessive tension. Does anybody know what would cause excessive tension?
Too much dope shrinking?
Too much dope. Yep, the heat will not actually do it. The dope will. Dope is going to continue to shrink over the years, and so it can actually get too tight, and it can actually, bend and damage the airframe or the fabric. So we have to take that into consideration. If you have fabric that's too tight, depending on the system, you might be able to get it to loosen up a little bit by rejuvenating it, but otherwise you're going to have to get out the razor, unfortunately. If the fabric is loose and has wrinkles, what would cause that? Does anybody know?
Proper shrinking?
Improper shrinking, yep. And improper could be not enough, or it can be too much. If you overshrink polyester fabric, it will crystallize and lose its memory. So what will happen is, we had one of these out in Alaska one time that they actually were blaming us for it initially, but what happened was they shrank it to over 400 degrees, and they had the wrong instructions. And, looked great, it was nice and tight, it was all finished out, and they rolled it outside in Alaska, of course. Well, the airframe shrinks when you go outside, the fabric didn't. So all of a sudden the fabric was hanging off of it and didn't get signed off. They had to redo the whole thing. So be very careful about shrinking the fabric. Use a quality iron. We recommend a Toco ski wax iron. Tecna is a paint gun. A Toco ski wax iron can be had on Amazon for about $100. They have a digital thermostat. They don't have an automatic shutoff, and the sole plate is very even, and they will only max out at about 350, so you can't damage the fabric with it. So we really like those. Another thing that if you have loose fabric and wrinkles that you want to look at is airframe damage. If that airframe's been bent, we could have loose fabric. So, if you got loose fabric, inspect that airframe real carefully. Coating conditions. This is most of what we see, really. I know if anybody's worked on fabric aircraft, you've seen the cracks and the ringworms that happen over years. Most of these coatings over time do get brittle and they start to crack. And that becomes a big problem. Once they start to crack, generally they start to delaminate as well. You're going to see them wanting to start to come off the fabric. And what happens there is we get our UV exposure. Now our kryptonite's getting down to that polyester. So we have to be very careful about that. And another issue we have sometimes is adhesion of your tapes and your seams. Make sure those are still good and tight. Remember on a glue joint, you have an overlap joint and you've got a finish tape over top of that. Well, that finish tape is part of that joint. So if that finish tape is coming off a glue joint, we're weakening that glue joint. Not as much of an issue where it's just going over a stringer, providing extra protection, but at the same time, it's also going to expose to UV, so we have to be careful there. Okay, a little bit farther along in the 4313. Condition of the fabric covering must be determined on every 100-hour and annual inspection because the strength of the fabric is a definite factor in the airworthiness of the airplane. I would agree there. It won't fly very well without the fabric. This is the part we really need to understand here. Fabric is considered to be airworthy until it deteriorates to a breaking strength of less than 70% of the strength of the new fabric required for the aircraft. Now we got to break that down a little bit because that's a little bit confusing. We're going to go back to this illustration here. So the first thing we got to see is what was this airplane certified with, right? if this airplane was certified with, let's say for the sake of the argument, heavyweight cotton, right? What is our spec going to be? Here's our heavyweight cotton. Here's our tensile strength. So we got to be at 70% of this tensile strength, which is 56 pounds. Now, what we're talking about here on tensile strength, you know, you guys have probably seen or done punch testing on fabric. What we're looking for, though, is tensile strength. So the technical test, and we're going to get into this in a minute, is to pull the fabric apart and see where it breaks, at what it breaks at. So we're going to show you how to test that in a minute, but the key is, if the airplane was certified with cotton, we're going to go to cotton as our specification. This is what it has to meet. This is minimum. You're the IA, you can make it meet a higher standard if you don't like it. You know, you have the final call on that, but it cannot be below this. If it was certified with the medium weight cotton, it's going to be 46 pounds. If it's a newer airplane, if it's certified with polyester fabric, let's say your mall rolled off the assembly line with 101 Seconite on it, we have to be at 70% of this number now. So that's going to be our minimum on that. So what it was certified with is the key to the standard that you test it for. Does that make sense? If you don't have a standard, if you don't have good information, we're going to fall back to the 4313. If we have a wing loading less than 9 pounds per square foot and a VNE of less than 160, the minimum brake strength is 46 pounds per inch. That would be our medium weight cotton. That's absolute minimum. We cannot be below that. If we have a wing loading over 9 pounds per square foot or a VNE over 160, now we're in the heavyweight cotton standard of 56. But again, this is if we can't find any other documentation on it, this would be our fallback bare minimum. And gliders, some of the gliders or experimentals, a lot of the experimental light sport will use your lightweight fabric. If that's the case, you can go down to 35, but that's kind of a rare exception. So how do we test it? Mechanical? Yes, sir.
Yes, sir. You said that's what you fall back to, so can I use the word default to? And would that be what you default to if you can't find anything else?
If you can't find anything else, that's it. If you know the airplane was certified with polyester fabric, you know, you better use at least one of those. Even if you can't identify which polyester, I would use one of those for standard. It's going to be a little higher. But if it has polyester on it and it was made in the 40s, we know it was certified with cotton, right? Polyester didn't come on until 50s. So, you know, you're going to have to decide as the IA which standard you're going to hold to and run with it. But nothing would fall below those minimums. So fabric testing, this is again out of chapter 2, the 4313. Mechanical devices used to test fabric by pressing against or piercing the finished fabric are not FAA approved and are used at the discretion of the mechanic to base an opinion on the general fabric condition. So they're a handy tool, but that in of itself is not technically going to make it airworthy or not. I've got one here that, as far as I know, it's the only really popular one out there, and that's a mall tester. And we can pass this around. Basically, it's got a machine tip. It's a very accurately machined tip, and we're going to press this down into the fabric, and we're going to read on this scale. The unique thing about the mall tester, this is not reading the pounds that you're pushing down. This is designed to equate to pounds in tensile strength of the fabric. So they went to a lot of research and development to come up with this scale. So basically what you're going to do is, if you've got a customer's airplane in there, let's say 46 pounds is our standard that we're shooting for. We need to go to 46 pounds on this scale, and it doesn't pop. We're good. If we really want to know what the ultimate fail of it is, we can push it until it fails. This might not even fail. It's brand new fabric, so I can't quite get it to fail. But I'll pass this around. You guys will see what it does. You can play with it. These are not cheap, $500. So but yeah, give that a play with and you'll see what that is. It's not approved. It's not the sole determination. You as the IA are the sole determination. Ultimately, it comes back to this word right here. So that's what you're going on. You can use that. It's a, there we go. It's a great tool. It gives you a great opinion. If it fails that mall test, I would definitely not sign it off. If it passes that mall test, you may still have concerns about it. You might want to test farther. If we want to test farther, this is the actual standard. This is the set standard that we're looking for. And again, this is 4313, Chapter 2. They want us to cut 1.25 inches wide, 4-inch long sample from a top exposed surface. Your customer's not going to be real thrilled when you tell him you want to do this, but this is the standard. You can tell him, hey, you know, if you want it signed off, this is what we have to do to test it. So, but you know, you would be very concerned about the fabric at this point to go to this length. So we're going to cut this sample out from an exposed surface. Remember, the UV is what deteriorates it, so that's where we want to get the most exposed surface we have. Remove all the coatings. You don't want to test it with the coatings. And then you're going to ravel the threads off the edges until you have exactly 1 inch of fabric. You're going to clamp each end between suitable clamps, anchor one to, you know, a table or whatever, hang weight on the other end, and you're going to add weight until that fabric fails and see how much weight you have. That's going to tell you your tensile strength. So, you know, now you're seeing what it is that we're actually testing. We want to know the failure rate of that as we pull it apart. The mall test is designed to equate to this standard. You know, it's not going to be 100% accurate, but it'll get you in the ballpark. So if we're going to test the fabric and we need to find out what standard it is, we need to verify what it is. So we need to identify it. You know, we could have cotton, polyester, or glass fabric. We need to establish that first. You know, it's not too hard to determine those fabrics. Cotton, you know, is going to have a beige, brownish look to it generally, or a purple look to it if it has a fungicide on it. You're probably not going to run across that much. Polyester is mostly what you're going to run across. Polyester should be stamped with a PMA stamp. However, those can be hard to find. Superflight stamps theirs on the edge. Well, where's the edge of the fabric? Usually it's either under a seam or it got cut off, right? So they're pretty hard to find. Seconite and polyfiber do put them out in the middle somewhere, so a lot of times you'll find those. Superflight is kind of a purplish blue color. Seconite and polyfiber are going to be black. So anyway, look for those. After we identify the fabric, we still need to identify the coating system, right? Because they could use any one of those STCs with any one of these fabrics, really, in general. So we can't really assume that we know what it is. Just because it says Superflight doesn't mean it's a Superflight coating system. Hopefully, it's in the logs, right? And if you guys do fabric work, please put it in the logs. Make it easier for the next guy. But a lot of times, we'll find logs that, you know, fabric repaired, you know, whatever. It doesn't tell us what it was, unfortunately. So hopefully it does. It should. It's supposed to. And you know, if you look at it in logs, sometimes, you know, we run across airplanes that, hey, it's covered in polyfiber, and we look on there and this is not polyfiber. You know, things get done, logs get lost, things happen. So verify what it is before you go too far on it. Okay, we're going to get into repairing a little bit. How much time do we have? We got a little bit. Repairs must be made according to appropriate data, right? So we got to know what it is before we can determine what the appropriate data is. We talked a little bit about appropriate data, type certificate data sheet, STC data, you know, various forms of that depending on what it is. And like we said before, you know, you can repair anything with our system legally using our STC. If you can't identify it, you know you're okay with our system. So that's a huge thing for us.
I've got a question.
Yes.
If you can repair any of them, is that just, say you had an airplane covered in dough, you need to put a patch on it, can you paint dough for the Stewart system? You have to use the Stewart system as a top there.
That's a tough question. Where I would come down on that is, will it work from a practical standpoint? Absolutely. The question becomes the legal standpoint of it. I would say yes, especially in a minor repair, because you know that's what that airplane has the STC for, that dope. So you should be able to use that. If you're recovering, if you're doing a major repair, I would not. I would use ours.
So the dope will attack the eco bond.
It won't bother it at all. No, you're in good shape. And the reason that ours is able to repair any other system is because all of our products have a mechanical bond, not a chemical bond. So all of our products are actually, you know, grabbing hold of that physically. It's not a chemical that's melting into that layer like you would have in the other systems. That's the big difference. But having said that, yeah, you can, I mean, we've had people put everything on it in the experimental world. I mean, there's guys rolling latex on it. I mean, house paint. So, but yeah, all the major paints, Ranthane, everything, all that stuff has been put on it.
Do you match paint colors pretty well with your system, or is it?
Yes, we can match the color and the sheen, and I'll show you some examples of that here in just a minute.
Your STC doesn't require you to use your top coat. You use anybody's top coat.
If you're doing a major, yes, that would be part of the STC.
Your top coat.
Our top coat would be, yeah. If you're doing some minor repair work, yeah, I would just use what's on there, because it's such a hassle to try to, you're putting a silver dollar patch on there, and I don't see any reason why you can't use the existing top coat on that. And if anybody ever questioned it, you could put our top coat on it and then put the other stuff over it as a repaint, and then there's no question about it. So it's kind of, you're really splitting hairs, I think. So we've seen no compatibility issues at all. So this is what determines major and minor repair, and you guys as the IAs are going to have to come up with your interpretation, or ask the guys at the FSDO. AC 4313 says, so we're repairing a new fabric section over 2 adjacent wing ribs. I think what they're saying is you're putting a new piece of fabric that goes over 2 ribs, right? That's my understanding of that. So if it goes over 2 ribs, you got to do 337 as major. Now we come down here to part 43, Appendix A, which really this supersedes the AC. So this is really this is the enforceable part here. And it's actually looser in my interpretation. Repair a fabric covering involving an area greater than that required to repair 2 adjacent ribs. Now, if you got to repair 2 adjacent ribs, you pretty much have to open up 3 bays, right? If you're going to get to both sides. So that's a considerably larger area than the AC 4313. So anyway, and actually, if you have to open up 3 bays, you're going to put fabric over 4 ribs, right? So this is 2 totally different things, which, is not unusual for the FAA. But anyway, that's the standard. So, interpret that however you want to as far as that goes. But if you do a major fabric repair, you do have to file 337, list the STC. Also, if you do any complete control surface, any complete component, that is considered a major. So, okay, steps to repairing. Now we're going to cover 2 different ways. One is if it's our system, if the airplane is covered in our system and you repair it, and the next one will be if it's covered in some other system. There's a little bit of a difference. If it's covered in Stewart Systems and you're going to glue on a patch, all you have to do is scuff the top coat. You don't have to remove it. We use a 320 sandpaper, red Scotch-Brite, anything like that. We got to take the shine off. That's what's going to give us adhesion. If it's glossy, it's not going to adhere well to it. If you've got a small patch, you can just wet glue it. You can put wet glue right on it, lay the patch right down in it, put more glue over top, wipe off the excess, and you're done. It's adhered. If you have a larger area, you're going to find it's a lot easier to do like you would do if you were covering the airplane. You're going to put the glue on, EcoBond on. You're going to allow it to dry 10-15 minutes. It's going to be dry. It'll still be a little tacky, and you can kind of press the fabric in. It'll be a little sticky. Take your iron and you can heat bond that then exactly where you want it. Get it to all lay down the way you want it. And you're going to run wet glue down through it, wipe off the excess, and now it's bonded. And of course, if you're doing a very big piece, you're probably going to want to put finish tape around the seam as well. That's going to be part of your glue bond. The nice thing about it too is if you have a glossy paint in the area that you haven't scuffed and you get glue all over it, don't worry about it. Just let it dry. We have a little glue eraser. You can just rub it right off. No problem at all. Very easy to work with. If you've got a finished airplane and you suddenly realize you need an inspection ring where there isn't one, you can add that on. Again, if it's our system, you're going to scuff the paint where you're using the glue. Glue your ring on, glue your doily on, finish it all out, cut it out, you're good to go. So, very nice when you're working with our system. If you are using a different system, if it's not Stewart Systems, the big difference is the coatings have to be removed at least down to the UV layer. You can't bond directly to the paint. What we've seen is the paint doesn't necessarily have an adequate bond to the UV layer to be adhering fabric to. And so that's why we've put that in the STC. And keep in mind that whatever you're gluing to has to have good adhesion to the fabric, right? Otherwise, your fabric isn't going to stay on. If it's delaminating, you know, you just go down to the bare fabric, and then you know for sure. But if you're satisfied that the coating is good, you can glue to the UV or the primer layer. Okay. Practical example, we're going to get one that we just did here recently. This is actually an experimental, but it's what we had some pictures of readily available. This is a Quad City Challenger aircraft. We went in and replaced a spar. He had bent a spar, did a ground loop with it. This is Polytone back here. This is Polyfiber system. This is Stewart's, so you can see the color of our glue is pretty easy to identify. You can see where we have a seam here, gluing onto the polyfiber fabric. We took our finish tape on down a little farther. Here's a little bit more up close. We don't have finish tape on here yet. We need an 1.5 inch overlap, but we've scuffed the Polytone. We've glued right onto it because it's experimental, and we know this is, you know, Polytone. We know it's good adhesion. We don't have to worry about it. So if it was certified, you would take the Polytone off. You could do it with MEK or sandpaper, but we've glued right to that. Putting our rib stitch rivets in. And here you can see the finished glue joint. This is on the bottom of the wing, but you can see the overlap here, and then we've got this edge of it roughly centered in that finish tape. We've gone over top of it, so that's a complete joint there. The next step, and this is, we're sealing the weave right here with EcoBond. Now if you have a revision 2 manual, you're going to see sealing that weave with EcoFill. You can do it either way. We prefer to do it with EcoBond. We're diluting EcoBond 3:1, 3 parts EcoBond, 1 part water. Brush 1 coat of it in. It'll soak right in, lay down flat, dry, and you're done with sealing the weave. And we'll spray all the EcoFill on for our UV protection. Really streamlines it, makes it nice. There we go. We're spraying the EcoFill on. So once we completed our repair, we scuffed the rest of the Polytone, and we painted the whole thing with EcoFill to make it easier. No sense trying to make a paint edge in the middle. And when it was all done, we painted it in an olive drab that we custom matched to the existing finish.
You don't have to have a paint booth?
You know, a paint booth is going to give you better results to control dust and everything. Do you have to? No, you definitely don't have to. You know, we actually paint it in here, which, yeah, it's kind of a makeshift paint booth. We're gonna build a better one, but we do have good ventilation in there. Lighting is less than I'd like it to be.
Pressure spray or suction, what do you prefer?
HVLP gun, and you really need a compressed air gun. Some guys have tried turbine sprayers. It works okay on primer and EcoFill, but it does not work well on the top coat. You'll have orange peel. Air is critical to our top coat. You're going to need about 13, 14 CFM to paint continuously. DeVilbiss Finish Line gun works great. The Techna Pro Light gun is a little bit better, quite a bit more money. But the Finish Line is a $225 gun. It's not horribly expensive.
So you wouldn't use the pressure pot?
I would not use a pressure pot. We haven't had much luck with that. But yeah, just the gravity feed HVLP does a great job. On the Finish Line, we'll run about 23 PSI. On the Techna Pro, we'll run more like 30. It will atomize really nice. So, but if you try to paint with not enough air, you're going to have a problem. When you do the paint, it's pretty forgiving on the environmental conditions. We're looking for 65 to 85 temperature range. Humidity 20 to 80% is good. In our case, we have a heated floor, so if the humidity is low in the wintertime, we just hose the floor down and it comes right up. So that makes it really nice. If you have really low humidity, you're going to get some orange peel and some dry spots. It's a little tricky. Mm-hmm.
What kind of volume of paint would you use to cover that wing? 2 quarts, 3 quarts, gallon?
I think we only used about 2 quarts on that. It's going to vary by color. That olive drab covered really well. If you're using like a real light yellow, it's going to take more.
And you would not use a pressure pot with a external mix gun?
Mm-mm. No, we don't have no issues with that at all. The HVLP gun works great. I mean,
well, you can put an HVLP gun on the end of a hose for a pressure pot. You don't have to keep filling the cup.
Well, you probably could do it. I don't really see a reason to. I mean, we filled the cup maybe 4 times to do that whole wing, but we're going through, multiple passes on it too. So, we're kind of waiting around anyway.
More
So
2 quarts, I'll put it in pressure pot.
okay. Well, give it a try. You know, it may work fine.
Depending on the volume you want on, right?
Yeah, you know, we're not putting a huge volume on, so you know, the key is with our paint getting it atomized really well. And the technique that we're using is, you know, we're putting a real light tack coat on, then we're going to fog coats, you know, a little bit heavier, but we don't want the paint to flow. It should look like 1,000 grit sandpaper. So we're going to build that up with about 3 fog coats, and then we're going to put a wet coat on, and we're done. So, and it's a pretty continuous process. You need
So that blends in all your gravelly looking sand.
Yeah, but it's got to be real fine. See, if your droplets are too big, you're going to end up with orange peel. That's why the air is critical. It's got to atomize it well. It's got to be really fine, matte finish. And then on your last coat, it's going to flow out really nice. This paint will flow for like a half an hour. I mean, it's really amazing. There's other questions? Huh?
So I've got a couple people who covered experimentals and use all the way to the top coats on the Stewart. A lot of them get frustrated because of runs and sags and paint. Is that just from being used to spraying solvent-based paints and the dry time and things like that?
Yeah, most people that are used to solvent paints put our paint on way too heavy. Our paint goes on really light. So, and because of that, we're really lightweight in our system. If you take a Super Cub, the fabric and all the coatings and everything comes out to about 30 pounds. So we're considerably lighter than I think anybody except maybe Ortex.
So you can change your technique, I guess, spraying your pure paints and put lighter coats on than what you could with the others.
It is a little different, and we do sell practice paint. You know, if we mess up a color or somebody has too much and they return some, we sell that as practice paint at half price. So I'd encourage, if you're not familiar with it, just get some of that and try it. It's not difficult at all, but it is a little different than solvents. Any Waterborne is going to be a little different. But any other questions before we move on?
What's your cure out time?
The cure time, attack time between coats is going to be around 15-20 minutes. It's going to be fully cured in about 24 hours. So you can handle it in 2-3 hours generally. That's Eco Poly. Eco Acrylic is a little quicker. So, but you'll want to keep it dust free for, I'd say, at least a half hour. It is fairly slow compared to some solvents. You were asking about color. Another repair we did on this particular airplane is in the nose area. So the fabric up here is new. From about here back is old fabric. And again, this is a polytone aircraft. So, you know, this illustrates where we painted, what work we did on it. And this is what it looks like when it's all done. And I know pictures don't really do it justice, but all this back here is polytone, and it blends in here a little bit. From here forward is Stewart's. So it's pretty much indistinguishable. If you're standing there looking at it, you wouldn't find a line. Now, because this is polytone, we put our flattener in it, so we have the full rate of flattener in this to match the polytone sheen. If it weren't for that, it would be very glossy. It still does have some gloss, just like polytone. It's a satin finish. It's not a true flat. But we can match virtually any color that you have. If you have some really exotic metallic, we may have trouble with it, but anything that's a standard color from any certified system will be no problem, and most other colors are no problem. So, is there any other questions on that? Yes, sir.
What's your chemical resistance like on the top coat? Is the top coat porous?
No, the top coat is every bit as chemical resistant as the other guys. Because it's a catalyzed polyurethane, there's no issue at all. Our Eco Bond and Eco Fill, Eco Prime, all those are very resistant to avgas. Autogas is a different story, and that's going to be with everybody's systems, because autogas, there's 140 recipes for autogas in the US alone, and it's constantly changing. So there's no way that we could ever even test it. I mean, it's constantly changing. It's a moving target. So we can't guarantee that it's going to resist autogas. Now the top coat does. We've never had any trouble with autogas on the top coat. It's when it gets on the back side. If you've got wing tanks, your wing tank leaks down on that EcoFill. That is going to cause a problem eventually. If it's a quick, if you get it fixed real quick, it may not bother it at all. We had a leak in the shop one time on a Stewart Systems airplane, and it leaked for about 2 weeks. And we saw just a little bit of rippling on it. It wasn't a big deal. That was with autogas. If you're doing a wing that has wing tanks, for example, if possible, spray some of our top coat underneath the wing tank on the inside of the wing, and that'll help protect it if you do have a leak. And make sure you have drain holes so it can get out. So take some precautions like that. One other precaution, A lot of times guys will mask an area and they'll spray the eco-fill and then they'll spray the top coat and then they'll pull the masking off. Now you've got a cross section. It can, if it's on a fuel tank neck or something, it can get in that cross section and get between those layers and cause some problems. So all you got to do is, once you've painted your eco-fill on there, pull your masking off and mask back a 1/4 inch or so, and then spray your top coat. You know, if it's aluminum, you'll want to etch it a little bit so you get good adhesion. But the top coat will stick fine to that aluminum, and then that covers the edge of the eco-fill, so you're in good shape. So little tricks like that. Any other questions?
So your finish coat will stick to aluminum?
It will. I mean, obviously we would recommend a primer, but in an area like that, I would put it right down to aluminum in a small band just to protect it. But normally, if you're painting aluminum, you would use Eco Prime or Eco Epoxy, and then Eco Acrylic for a top coat. If the whole airplane is aluminum, use Eco Acrylic. If you've got, you know, if you're doing a cub or something where you just have a metal cowling and boot cowling, stuff like that, just shoot the whole thing with Eco Poly. It's not necessary to have 2 different paints. But if you do have a metal airplane, the Eco Acrylic is a little tougher. It's a little harder. It'll buff a little better. It's a little less flexible. If you put it on fabric, it'll eventually crack. So we had some people inadvertently put that on fabric about 5 years ago, and it's just now starting to see a few cracks. So Eco Epoxy cannot be used on fabric. Eco Prime can. So if you're doing yellow, you would want to put Eco Prime over the Eco Fill. So you're not trying to cover charcoal with yellow. It'll turn out green. So we do have white Eco Prime for that. So, any other questions? Glad to see that we got some young folks here. That's one of the things that we love about our system is, you know, we had a customer call in one time and he said, you know, when I was a kid and my dad was covering an airplane, as soon as he cracked open a can of that stuff, he'd run us all out of the shop. And he said, I always hated that, and I'm not going to do that to my kids. And so he uses our system, and the kids are right out there helping him. So that's one of the wonderful things about it. I think we're about out of time. Any other questions real quick? Okay, well, stop by our booth, and if you got any questions, and hopefully my mall tester makes it back.